Hi students, let us understand curvature a little bit more closely in the context of plane curves. Later we will do or we will specialize for space curves as well. So first suppose that gamma of s is a unit speed curve in R2 in the plane. Now look at the unit tangent vector t at the point gamma of s. So vector t is equal to d gamma by ds, which is also denoted by gamma dot, where dot represents differentiation with respect to s. Okay. Now we will make a thumb rule. That thumb rule is this: rotate this unit tangent vector counterclockwise by an angle pi by 2. So I will get this vector. So this angle is pi by 2 counterclockwise. Call it vector n, but this vector depends on the point s also. So it will be denoted by n suffix s, the vector n suffix s. So rotate vector t, the unit tangent vector, by an angle pi by 2 counterclockwise. To obtain the unit vector n sub s. Why this is unit vector? Because t was a unit vector. I am just rotating that vector. So after rotation, the magnitude will not change, only the direction changes. So why am I doing this? Because I want to look at the curvature. Recall what is curvature? Curvature is defined as gamma double dot norm of this. But what is gamma double dot? It is t dot, norm of vector t dot. That means vector dt by ds, norm of dt by ds. dt by ds means rotation of the unit tangent vector t with respect to s. Rate of change of the unit tangent vector t with respect to s. But t is always a unit vector. So there is no rate of change of t in its magnitude. The rate of change of t happens only in the direction of t. See, for a vector, rate of change means what? A vector has a magnitude as well as a direction. So rate of change means it can be in the magnitude or it can be in the direction. But since vector t is a unit vector always, there is no rate of change of t in its magnitude. Only rate of change of t happens in its direction. Right? So at this point, unit tangent vector was like this. At this point, unit tangent vector was something like this. And at this point, unit tangent vector is this t. So this unit tangent vector rotates. And I want to study the rotation of this unit tangent vector t, and that will give me the curvature. that will give me the curvature. So that's why I am picking this unit vector, vector ns. Okay. Now what I do is okay, look at vector t. It's a unit vector. Since t is a unit vector, this means that its derivative t dot, that means gamma double dot. Gamma double dot is therefore perpendicular to t. T dot is perpendicular to t. This we have done earlier. If a vector is of constant magnitude, then its derivative is perpendicular to it. Therefore, gamma double dot that is a vector, it is perpendicular to t. That means it is parallel to ns. Is parallel to ns. And when two vectors are parallel, one is a constant multiple of the other. Therefore, gamma double dot equal to a constant multiple of ns. So that constant multiple, that will be denoted by kappa suffix s times ns. All these things will depend upon the point s under consideration. Here also gamma double dot of s is there. Okay. And this case, it is called the signed curvature of gamma. This is called the signed curvature of gamma at the point gamma of s. Let us take norm of gamma double dot. So what is norm of gamma double dot? It goes by definition the curvature. Okay, and the norm of gamma double dot is modulus of kappa s into norm of ns. But ns is a unit vector, so this is simply modulus of kappa s. Thus, what is the conclusion? The curvature is the absolute value of the signed curvature. Absolute value of the signed curvature. This is what we concluded. Now, this is the case if gamma is unit speed. Now, if gamma is not unit speed, what happens? If gamma is not unit speed but regular, then what is unit tangent vector? T, that is defined as the tangent vector of the unit speed reparameterization of this gamma. Okay. Similarly, ns, that can be taken as the units ns of the unit speed reparameterization of gamma, and kappa s, which is the signed curvature. These are defined as those quantities. So it is by definition those quantities, respective quantities of the unit speed reparameterization of gamma. So unit speed reparameterization, it will be denoted by gamma tilde. So let me write like that. Unit speed reparameterization, gamma tilde of S of gamma, where what is S? S is the arc length. Remember, reparameterization with respect to the arc length will give you unit speed curve. Okay. So let us compute these quantities for a regular curve, not necessarily a unit speed curve. So this is original interval. This is the original interval. Here t is the parameter, varies over some alpha comma beta, and here S, which is the arc length, varies over some interval alpha tilde comma beta tilde. From here to here you can go, from here to here you can go. Original curve, which is a regular curve given by gamma, and gamma tilde is the reparameterization of gamma. Therefore we have vector t. Look at the unit tangent vector, vector t, that was defined as the unit tangent vector of the unit speed reparameterization with respect to arc length of gamma. So t was by definition d gamma tilde divided by ds. Okay, but by chain rule, d gamma tilde divided by ds is the same as d gamma by dt into dt by ds. Into dt by ds. So let me write this as d gamma by dt divided by ds by dt, because dt by ds is 1 by ds by dt. So here this t is not a vector, this t is a scalar, but this t is a vector. So this is equal to d gamma by dt divided by what is ds by dt. What is s of t? S of t is integral t naught to t norm of gamma dot of tau d tau. So what is ds by dt? It is norm of gamma dot of t. Norm of gamma dot of t is d gamma by dt. So if gamma is regular but not unit speed, then what is the unit tangent vector vector t? It is d gamma by dt divided by norm of that. That is what the conclusion is. Now what is ns? Ns is obtained by rotating vector t by an angle pi by 2 counterclockwise. So that is ns. Ns is obtained by rotating vector t by an angle pi by 2 counterclockwise. And let us compute gamma double dot. So let us compute dt by dt. dt by dt. Because I may not be able to compute a unit speed reparameterization always. Because a unit speed reparameterization requires computing arc length, which requires a process of integration. Sometimes I may not be able to integrate it. So I want an expression for everything in terms of the original parameter t. This is the original parameter t. I want an expression in terms of t. So t is expressed, vector t is expressed in terms of the original parameter small t like this. So what is dt by dt? dt by dt is again by chain rule, dt by ds dt by ds into ds by dt. This is by chain rule. dt by dt equal to dt by ds into ds by dt. It goes like this. d vector t by dt equal to d vector t by ds into ds by dt. Okay. Equal to what is ds by dt? ds by dt is norm of gamma dot of t. So norm of gamma dot of t means d gamma by dt now what is dt by ds? dt by ds is t dot, right? In the previous slide you can see so dt by ds is gamma double dot, where dot represents differentiation with respect to s. So dt by ds is gamma double dot of s, but so you have gamma double dot of s here, gamma double dot of s. But what is gamma double dot? Gamma double dot is kappa sns pi as vector n as, and then you have this thing, norm of d gamma divided by dt. So this is the expression for dt by dt. Thank you.